Well, hey everyone, and welcome back. So we've been through 3 layers so far, just to review. There's our thin, solid outer layer, the crust. There's our thick, semi-solid, flowing mantle. And there's our liquid outer core. Now, of course, if we just covered the outer core in the last video, then you should know what's next. This piece in the very center, that is our inner core, the center of the Earth. Now, the inner core is distinct in a few specific ways. In that, due to its tremendous pressures, the tremendous pressures at the inner core, it's completely solid. Not liquid like the outer core, and not in that sort of plastic flowing state like the mantle, but the inner core is completely solid, much like the crust. It's got a radius of about 1,220 kilometers. And temperatures within the inner core, well, at the boundary with the outer core, it's roughly 5,700 degrees Kelvin, and it continues to increase going inwards. Now, one of the most interesting things about the inner core is its tremendous pressure, which is what keeps it in this solid state. So imagine the pressure that we experience here on Earth. Usually it's around 1 atmosphere, 1 atm. But down within the inner core, 1 atm is equal to 1 kilopascal, by the way. But down at the inner core, the pressure is 330 through 360 gigapascals. That should be a capital G. That is just massive. That's the kind of pressure that if you go down to, that's the stuff that just makes your head explode instantly, you know. Like, imagine yourself down in the Marianas Trench. That's the deepest point above the Earth's crust that we know of, and you know, down there, the effects of that massive of pressure lead to instant death, so imagining pressure even greater than that, infinitely greater than that, is just almost impossible to fathom. But anyways, as far as the composition of the inner core goes, it is believed to mostly be a nickel-iron alloy. Similar to the outer core. However, because at the pressures of the inner core, this alloy is actually denser than it's actually less dense than the inner core actually is. No, excuse me, it's more dense than the inner core actually is. We believe that there are also some lighter elements in there, such as oxygen or sulfur, but we're not entirely sure. Since I was having so much trouble saying it the first time, I guess I'll repeat it. The density of nickel and of this nickel-iron alloy at the pressure of the inner core, so at 330 through 360 gigapascals, is actually greater than the actual pressure of the inner core itself, so that, the actual density of the inner core itself. So that leads people to believe that there must be something making the inner core lighter, because if it were just this alloy, then the inner core would be that theoretical density. So that because of that, we assume that there are lighter elements. We're not exactly sure which, but we're pretty sure they're down there. So some fun facts now. The inner core was discovered as a result of readings from a seismograph, which showed that earthquake waves bounced off of the boundary between the outer core and the inner core. They couldn't travel through that solid, dense layer after going directly from the liquid outer core. So this was called the Bullen discontinuity, the place at which the waves bounced back. And that's just the boundary between the inner and the outer core. And finally, there's no huge concept to talk about as far as the inner core generating tectonic plate movement or our gravitational field. However, there is an interesting occurrence that we observe, and that is that the inner core is actually growing due to the progressive cooling of the outer core. Since the Earth gradually loses the energy it has within its core, we see that the outer core gradually loses temperature and that it can no longer maintain that liquid state. The iron and nickel within it drops down below its melting point, so it just turns solid. So in the future sometime, it's possible that there will no longer be an outer core and there will solely be one single core mass, and that will be what we refer to as like inner core today. Of course, that's not for a very, very long time. I think for every billion years or so, we lose about 100 degrees Celsius within the outer core at the boundary. So yeah, we're not anywhere close to a point. And you know, you saw how hot the boundary between the outer and the inner core is. 100 degrees Celsius off of that's barely anything. That won't cool much, won't cause much to change state. And that's all I really wanted to talk about for our final layer of the Earth, the solid, hot, huge pressure inner core. That's what you remember it as. It's just a sphere. It's relatively, it's the least thick if you're going by radius. If you're going by diameter, it's slightly larger than the outer core, but if you're going by radius, then it's the second smallest layer, of course, still much thicker than the crust. But, yeah, that's the inner core. Hopefully this was informative, otherwise good review. Hope you enjoyed, and I'll see you all in the next video. Ciao.